Hi, how are you? Alright, today I continue to study before we talk about interval estimation. Okay, today we hypothesis testing. We have two population, right? There's difference between two population, the mean. In this case, a small sample and should be independent. And standard deviation, unknown populations, standard deviation, but should be equal. Okay, continue. So hypothesis testing. So first of all, there are three assumptions mentioned satisfy. Okay. Do you remember assumption? Three assumption. One more time. For small and independent and unknown, right? Unknown standard deviation for population and equal. Okay, strict satisfied condition or assumption, and then we can using T distribution. So apply to make a hypothesis test difference between two population mean. Okay. So we valuable testing statistics about T. Okay. So you should remember. But anyway, when you find the T value, there's the one sample. This is two population. One population. Remember as a sample, mean of a sample bar, mean of a sample, and population, the mean population, right? And sample standard deviation. Okay, so sample mean subtract population mean and sample standard deviation. That time we don't know, right? Sigma unknown in this case. Okay, but right now two, right? Two population. Okay, so this is single and two. Okay, so value of mu1 subtract mu2 formula substitute from null hypothesis and standard deviation for sample. So do you remember we should know sample standard deviation SP from here, right? That is a pool standard deviation for sample. Okay, this one you should remember. Okay, I know it's calculation not hard, but you should memorize. Okay, I know it's kind of annoying. Sorry about that, but I have no choice anyway. All right, so let me show you the two example for using this hypothesis testing. So should be what two population. So we are looking for testing difference between two population should be what small and independent and unknown and equal standard deviation. Alright, that time using T distribution. Okay, so before example we're gonna using this standard deviation as distribution. Sorry, right now using T distribution. Okay, because small. If large is Z normal distribution, but this is small. That time should be using T distribution. Right? Alright, one example. Let me show you the two example. Today, first of all, two-tail test. Okay, which means equal, not equal, right? Remember? Okay, so this one same thing, small, independent, also standard is equal, also unknown. Okay, equal but unknown. Alright, so question. So brand 1, 14 sample, and they gave the mean value, the calories 23 for can. Standard deviation 3 calories. Okay. Second one, sample 16 sample for can, brand 2. So this one mean value is calorie 25 and standard deviation 4. Okay, and 1% significant level. The question is, can you conclude the mean number of calorie for can difference? Okay, difference for the two brand diet soda. Okay, so difference mean difference, not difference. This one two-tail test. So assume the calorie per can soda should be what normal distribution and two brand standard deviation population is equal. Okay, you get this condition. It assumes, right? All right. So from the information we get it significant level 1% and each brand, one brand, second brand. sample size 14, 16, and the mean of sample 23, 25 from the here, and standard deviation for sample and 3, 4. Okay, which means calorie 4 can. Okay, all right. So first the mu1, which means the first population will be brand 1. Okay, second one, second population brand 2. Okay, so first population, second population. All right. So this one for sample x1 is a sample for first population. X2 is sample for second population, which is brand 1, brand 2. Right? Do you understand that? And then we're gonna do what? 5 step, right? Remember. So first of all, first step, we decide what's the null hypothesis and alternative hypothesis, right? The first one, they mentioned that this difference, right, in here, difference. So we say null or alternative hypothesis difference. So null hypothesis, not difference. Okay, one more time. Null hypothesis, not difference, and alternative hypothesis, difference. All right. This one, what? What kind of test? Two-tail test. All right. All right. And the second step, what? What kind of distribution we're gonna use? So already mentioned here. One more time. Should be what? Normal, small, independent, standard deviation, unknown, which is equal to, right? That time using T distribution. Okay, it's clear? It's large size, is not, right? It's small size, okay? Unknown means we're gonna say sample, right? Simply. So should be independent, right? Alright. So we're gonna get into more. Second step, we're done, right? Third step, what's that? So we should determine rejection, one non-rejection region. Okay. So they give their significant level 1%, which means 0.01. So both sides, right? So each tail divided 2. So 0.005, which is 0.5%. Alright, so degree of freedom, we know the formula. N1, first brand sample, second brand sample size, right? Negative 2, right? So 28 is DF. We need a degree of freedom. So we are looking for T value when degree of 28, right? And area on each tail, I mean each corner, each side, right? There's 2 tail anyway. So each tail like 0.005 area. So from the you can use in the books, right? T value. So about here. So plus minus 2.763, where looks like here, this side and that side. Okay, big 2 tail tests. Remember, 2 tail tests. All right. So step 4, calculate the value of testing. So I'm sorry, you should remember anyway. What's the first SP? Pool standard deviation. This formula, and plug in sample size, standard deviation, sample size, standard deviation, and degree of freedom, right? So this number, and standard deviation for sample, right? Sample standard deviation. All right, this formula 2, plug in this number from this here, pool standard deviation, and each sample size, and get this number. And the T value, remember first time calculation, you should remember the formula. So S1 means sample, mean 2, right? Sample, and this one mu and mu2 should be same. Okay, because we mentioned there's an equal, not difference. So this number, all right? So we got the T value. Okay, now 5 step, we should we make a decision. This reject, not reject, but this number numbers here anyway, right? This number. So it looks like not reject. All right. So this number is greater than, which means which corner, this part, right? So critical point. So should be non-reject region. Okay, non-reject region. So fail to reject. So conclusion: the mean number of calorie can not different. But these 2 brand diet soda, so which means diet coke or diet soda will be same. All right, using the book that mentioned that, but I add to you for you the P value, make a decision, right? So T value from here, right? T value, and degree of freedom 28. But book, when you look at the table, not exactly this number, close number, which means 1.701 degree of freedom, about 0.5%, but it's both sides, so times 2, so 1%, no, 10%, right? 0.1. So our conclusion, fail to reject. So significant level from the given this number, right? This number, so 0.01, but our got the value, p value, right? So 0.1, so 0.01, 0.1, so greater, so p value significant level, also not fail to reject, right? So from there we're gonna take it null hypothesis, right? Understand that, right? All right, it's a similar, not big difference, only is issued the memory formula. Sorry for that, but you have no choice anyway. All right, move on. Next example, for right tail test. Okay, should be like greater, right? Greater. Left tail test, less than. Anyway, we got right tail test right now. Sample, same, small independent, right? Small independent equal unknown. So, first of all, sample size 15 sample, and the New York State, and the mean value 28.50 hours, and standard deviation 4. All right, sample size, mean, and standard deviation for New York and California. So sample size 16, and the mean is 23.25 hours, standard deviation 5 hours, right? So 2 sample and 2.5 significant level. So question is, can you conclude, what's the conclusion? Mean time spent watching TV by children in New York State is greater, right? Greater, which means right here, greater than California, okay? So we have 2 states and compare which state is the most spent time watching the TV for children. Maybe greater than Korea, right? Korea right now. But depends on school anyway. Anyway, here, assume the time might get large a lot anyway. So, assume that normal distribution, both population and standard deviation equal. Okay, as also unknown. Alright, so get the information, significant level here, and New York State, California State. Anyway, sample size 15, 16, mean of sample, this is 28.50 hours and 23.25 hours. Looks like New York State. They watch more. And standard deviation 4, 5. Right. So first one sample from New York State. Second is from California State. Right. So New York State, California State. Right. Not New York City. So each one a sample. The mean of sample for each one, population 1, population 2, which means x1 means California, sorry, New York State, and x2 is California State, right? So we have 5 steps, right? Same thing. So null hypothesis and alternate hypothesis. Alternate hypothesis, they mentioned the greater, right? So it's not greater for null hypothesis. So no, null hypothesis, right? Alternate hypothesis, just greater. Okay. Greater means what? Right tail test. Okay, right tail test. Right, one more time. They mentioned that conclusion greater, right? So alternative test, alternative hypothesis from the question. Okay. Okay. Second, what kind of distribution we're gonna use? So same thing. Normal, small, independent. Standard deviation means what? Unknown. Also equal. That time t distribution. Okay, so that's condition, right? Okay, t distribution. All right. So continue with step 1, 2 with 5 step, right? So third step, next one. So that's information, same thing, right? All right. First, third step. What is that? Determine rejection, one learn rejection region. So, first of all, significant level 2.5, which one 0.025, this area, and degree of freedom n1, n2, minus 2, which means 29, okay, 15, 16, and t value degree freedom area, this one 2.045 from textbook, right? You can look at the table. So how it looks like, just like that. Because right here, the 2.045, right? Now calculation part, sorry again. Should remember, right? Same idea. Sample size, standard deviation, sample size, standard deviation, and degree of freedom. Got this number, right? The full standard deviation. So we find standard deviation for that. The formula again, plug in, all right? This number, and our looking for t value using that. This one, this number. So should be this one going to be 0 anyway. Oh, sorry, 0.0. Okay, this number. Alright, so make a decision. Compare this number to this number. So 3.24 looks like about here. So rejection, right? So here's greater. So falling into rejection region, which means here, right? So should reject. So mean time spent watching TV, New York is greater than California. You can see the number, right? So it looks like New York's a lot, right? Even the standard is a little bit, right? It's a lot, so we can see greater. All right, so p-value. So t-value from here, right? So also same thing, standard deviation. So this one for degree of freedom. When you look at degree of freedom, there's no 3.24. So close number 3.39. Degree of freedom. That's p-value about 0.001, right? 0.1%. All right. So we compare significance level, this number, right? So it looks like a 0.025 is 0.001 is greater. So this is reject. All right. So it looks like a similar. So first, one population, two population, kind of almost same idea, but only calculation part is a little complicated. Everything same, right? So we're gonna find the test statistics, compare t value, z value, but book doesn't mention the p value. But I think it's the same idea for chapter 9. All right. All right. So let me give you the homework. So check yourself, and then we can talk about later. All right. Thank you. Bye bye.